Welcome to the Checkpoint to Jumpstart training series. In this training series, we will be looking at the different Checkpoint CloudGuard product lines. The Checkpoint CloudGuard is a suite of products and solutions that can secure your data and virtual networks in the cloud. In this training video, we will examine different CloudGuard capabilities that can be used to protect both your cloud assets and your network assets. My name is Manuel Joaquin, and I will be your technical trainer for this training module. But before we get started, let's take a quick look at the agenda for this training video. We're going to break this training video into 4 separate lessons. Each lesson will be a separate video. You can view them all together in one viewing or consume them separately as needed at your leisure. First lesson will be about cloud challenges. Here, we will first talk about cloud computing and the value that it can bring to an organization and why more and more customers and enterprises are adopting it. Then, we'll talk about security in the cloud. Here, we will look at some of the security challenges, limitations, and concerns when moving your assets into the cloud. Third, what is CloudGuard? Here, we'll look at some of the Checkpoint solutions for cloud security, which are branded and grouped under the CloudGuard product line. We will list the individual products in this product line to give you an overview of their capabilities. Finally, we'll talk about security with CloudGuard. Here, we're going to break down each CloudGuard product and discuss how the CloudGuard product line offers some unique solutions to secure a dynamic and elastic cloud environment. In this training video series, we will talk about cloud computing, so let's go now into our first lesson. In this lesson, we will talk about cloud computing and the value it can bring to an organization, and why more and more customers and enterprises are adopting it. Let's first examine what are some of the cloud challenges that can prevent customers from adopting a cloud posture. Let's talk about cloud computing. More and more customers are now moving their network infrastructure into the cloud in order to stay productive and competitive. Cloud adoption is forecast to reach $620 billion by the year 2023. This is a growing industry, and the landscape is becoming increasingly sophisticated and competitive, with multiple cloud providers popping up to satisfy the demand for strategic cloud services. And there are a few reasons for that. But first, let's examine some of the challenges when using traditional networks, and then contrast this with cloud computing. In traditional networks, it can take several weeks to set up and configure a server on your network. You need to purchase the hardware, you need to install the operating system, you need to install and harden the software, and finally, you need to configure and connect it to the network. Another aspect in traditional networking is that when you purchase physical equipment, you always need to project for future growth. You usually need to purchase a server or an appliance with higher capacity needs than initially required, just to compensate for future growth and expansion. But in the meantime, the equipment will be underutilized. At a later stage, your bandwidth demands may exceed the hardware capacity, which means you'll need to upgrade your hardware or even purchase completely new hardware. In addition, traditional networking requires internet connectivity and security, which means you need to purchase supplemental equipment like routers, switches, firewalls, and antivirus solutions, and even an IPS appliance, just to be sure that you have not only connectivity, but also security. Now, in comparison, let's take a look at why a cloud implementation might be a better solution. First off, the cloud is dynamic, meaning you only pay for resources that you need. It's like being billed for an utility such as electricity or a heating bill. Customers can rent equipment in the cloud and spin networks and workloads as needed to align with business expansion, demands, and potential business growth. the cloud is agile. You don't need a big team to set up hardware and networking. You can just spin up a virtual machine in the cloud within minutes. And there is no need to manage the equipment, as the cloud provider does that for you. The cloud is elastic, meaning you can expand and collapse the equipment in the cloud as you grow or shrink your activity. Finally, the cloud is mobile, meaning you can provide access from anywhere. In the age of bring your own devices, this offers workers the flexibility to work from anywhere at any time. That brings us to the end of this lesson. Let's quickly recap before exiting this video. This was just a brief summary to give you a sense of the power of cloud computing and some of the advantage over traditional computing, which explains why cloud adoption rates are continuously on the rise. And so that completes our first lesson. In the next lesson, we will discuss security challenges when moving assets into the cloud. I will see you there. Welcome to Checkpoint Jumpstart Training Series. In this training series, we'll be looking at different Checkpoint CloudGuard product lines. In this video, we'll examine different CloudGuard capabilities that are used to protect both your cloud assets and also your network assets. This is Lesson 2, Security in the Cloud. In this video, we'll look at some of the different security challenges, limitations, and concerns when moving your assets to the cloud. Let's get started. There are a few challenges that any organization faces when moving their network infrastructure into the cloud. One of the main concerns is security. Customers need to be sure that their cloud assets are as secure or even more secure than their data centers. Gartner predicts that through 2022, at least 95% of security failures in the cloud will be caused by the customer. So next, let's take a look at some of the key challenges with regards to the cloud. Security in the cloud poses some challenges. Nearly 2/3 of organizations see security as the biggest challenge for cloud adoption. Cloud vendors advocate for a shared responsibility security model. The cloud vendor will secure the cloud equipment, but it's up to the customer to secure the data in the cloud. The cloud vendor's main responsibility is to secure the cloud infrastructure, and they do so comprehensively with multiple regions across the globe and with multiple availability zones and data centers, in addition to physical access and perimeter security. But ultimately, it's up to each individual customer to secure the data and assets that they hold in the cloud. The solution is that CloudGuard is a cloud security product. When you spin up a virtual network in the cloud, the default position is that everything can communicate with everything. The cloud vendor has made this as simple as possible because you want to have maximum connectivity in the cloud. Therefore, security becomes more of a secondary concern. The solution: CloudGuard offers top-of-the-line security checks. Another factor is that since data is in the cloud, it needs to be accessible. But who should be able to access it? The cloud vendor offers some very basic native security checks that you can implement, such as access control rules, but that's as far as it goes. There's nothing that prevents malware infections. Solution: CloudGuard protects against unauthorized access. Another consideration when moving into the cloud is that the cloud is dynamic, meaning it can expand and grow as needed, and new workloads can be spun up. but various departments of the customer's company obviously want full connectivity to other company assets in the cloud and also on-premise. They don't want to be bogged down with weeks of change management paperwork requests, like what firewall rules need to be created, which network or host objects need to be added. The security solution has to be dynamic as well, to grow organically and to keep up with changes that occur within the customer cloud. Solution: CloudGuard is highly scalable and can expand and collapse as needed. The good thing about the cloud is that you only pay for what you use. You can spin up the workload during peak hours and free them up during business downtimes. Solution: CloudGuard is a cost-effective solution with some of the best return on investment. At Checkpoint, we believe that the future is in the cloud, and that Checkpoint CloudGuard is the security solution of the future. That brings us to the end of this lesson. Let's take a quick recap before exiting this video. In this video, we learned that CloudGuard is a cloud security solution, that CloudGuard offers top-of-the-line security checks, that CloudGuard protects against unauthorized access, and CloudGuard is highly scalable and can expand and collapse as needed. CloudGuard is a cost-effective solution with some of the best return on investment. That completes our second lesson. In the next lesson, we will discuss security challenges when moving assets into the cloud. I'll see you there. Welcome to Checkpoint Jumpstart Training Series. In this training series, we'll be looking at Checkpoint CloudGuard product line. In this training video, we will examine different CloudGuard capabilities that are used to protect both your cloud assets and also your network assets. This is Lesson 3. What is CloudGuard? In this lesson, we'll look at some of the Checkpoint solutions for cloud security, which are branded and grouped under the CloudGuard product line. We will list the individual products in this product line just to give you an overview of their capabilities. Checkpoint offers the CloudGuard product line, which is Checkpoint's answer to cloud security, just like our traditional on-premise security offerings. After all, Checkpoint invented the Stateful Inspection Firewall back in 1993. Since then, we have been a Gartner Magic Quadrant firewall leader for the last 22 years straight. We have been recommended by NSS Labs 16 times in the past 9 years, and we constantly exhibit the industry's best catch rate. We serve over 100,000 customers around the world and secure over 90% of Fortune 500 companies. And with over 25 years of security expertise, with multiple industry awards and accolades, Checkpoint now brings the same award-winning security solutions from the customer premise to the customer's cloud. Not only do you get the same level of security and peace of mind within the cloud as you get with traditional security products, but we've also added multiple native cloud security solutions and products to help you secure your cloud environment while also helping you stay compliant. All this, and in addition, helping you mitigate threats. With Checkpoint CloudGuard, we believe that the cloud can be as secure as your physical data centers, and cloud security can be as dynamic and agile as your cloud. In addition, Checkpoint Cloud Security has been adapted to handle many cloud security challenges, such as elasticity, agility, dynamics, high availability, and other cloud challenges. CloudGuard is not just one security solution, but it's actually a suite of security products and capabilities that help customers secure their cloud just like their on-premise security. Let's dive a little bit into this security solution, into the security capabilities. As mentioned already, CloudGuard is a suite of security solutions that can be used to protect your cloud assets. Just to give you an overview, here is just a brief list of 5 broad security solutions that are part of the CloudGuard product line. We offer the CloudGuard Network Security and Threat Prevention solution. We also offer CloudGuard Security Posture Management. And on top of that, we offer CloudGuard Cloud Intelligence and Threat Hunting. In addition, we offer CloudGuard Workload Protection. And now we also offer CloudGuard WAP, Web Application and API Protection. We will dive deeper into these 5 solutions in the next lesson. But here I just wanted to inform you on how broad our CloudGuard solution is. And these solutions not only protect the public cloud, but also often extend to the private cloud. And there's also another set of CloudGuard security solutions that we'll talk a bit more about them in the next lesson. I know I've stressed this already, but I cannot stress this enough that CloudGuard utilizes over 25 years of Check Point experience and leading security technologies to secure your assets in the cloud. CloudGuard Network Security Solution offers a set of products that can secure not only your public cloud security assets, but also your private cloud security assets. CloudGuard is unique in being a truly multi-cloud security solution. It can be used to secure all your popular cloud platforms, on-premise data centers, and public IaaS infrastructures, regardless of your cloud of choice. With CloudGuard, your cloud security will be managed from a single pane of glass. From one console, you can share policies and rules between different cloud suppliers, and also gain visibility to your cloud security posture across different platforms. That brings us to the end of this lesson. Let's quickly recap before exiting this video. CloudGuard is dynamic and agile. CloudGuard is elastic. CloudGuard is high availability. CloudGuard is a suite of security products. CloudGuard is a suite of security capabilities to help enterprises secure their cloud journey. That completes our 3rd lesson. In the next lesson, we will discuss how CloudGuard addresses certain security challenges. I'll see you there. Welcome to the Check Point Jumpstart Training Series. In this training series, we'll be looking at Check Point CloudGuard product line. In this video, we'll examine different CloudGuard capabilities that are used to protect both your cloud assets and your network assets. Lesson 4, Security with CloudGuard. Finally, we're going to break down each CloudGuard product and discuss how the CloudGuard product line offers some unique solutions to secure a dynamic and elastic cloud environment. Let's get started. Check Point offers the CloudGuard product line, which is Check Point's answer to cloud security. Just like our traditional on-premise security product offering, Check Point offers a suite of CloudGuard security products which are designed to run in your single cloud or multi-cloud ecosystems. For the purpose of this explanation, I'm going to categorize CloudGuard security products into two main categories. The first category is products that allow you to protect your assets that you have lifted and shifted into the cloud. To make sure that these cloud assets, applications, and workloads are secure and protected, CloudGuard products are protecting your public cloud assets. The second category is products that allow you to protect your physical assets that are located on-premise. These assets that are either located on-premise, but the security solution, the security products, can be hosted in the cloud. Here, Checkpoint Security Solutions are hosted in the cloud, and they are protecting your physical assets that are on-premise. Let's take a look at the first category of Checkpoint CloudGuard solutions. Here, we're focused on protecting your assets that are located in the cloud. Network Security Solution, formerly known as CloudGuard IIS. This is Checkpoint's solution for protecting your data centers that are on the public cloud, and even data centers that are running on customers' private cloud. CloudGuard Cloud Security Posture Management, formerly known as CloudGuard Dome 9. This is Checkpoint's solution to help you establish industry compliance, governance, and best practice with your public cloud infrastructure. This solution is spread across not one, but many cloud service providers to make sure that you have not unintentionally left any security gaps in your cloud data centers. CloudGuard Threat Intelligence and Threat Hunting, formerly known as CloudGuard Logic. This is where we aggregate and correlate logs to help determine if there are any potential vulnerabilities or intrusions on a network. Additionally, this solution takes actions in remediating threats by containing breaches or disconnecting intruders to safeguard your data. CloudGuard Workload Protection, formerly Protego, which was an acquisition by Checkpoint. This solution helps core developers and core operators to assess code and also secure and harden workload deployments. It makes sure that there are no vulnerability code or embedded threats that were perhaps accidentally or unintentionally added during the deployment or the development stages, either when configuring workloads and also when rolling out workloads virtual machines into the cloud. Checkpoint CloudGuard WAP. WAP stands for Web Applications and API Protection. It is an application security solution to help protect your cloud-native applications. Basically, it's using machine learning to make a rating assessment based on history to determine and predict user and application behavior and block anything outside of the norm. All of these 5 CloudGuard solutions can run independently, but it would be much better to run them together for a complete and first-rate security solution. Each of their individual capabilities complement each other to achieve comprehensive, optimal cloud security. In this Jumpstart training video series, we'll focus on these main CloudGuard solutions. Next, let's take a look at a second category of Checkpoint CloudGuard solutions. Here, we're not so much focused on protecting your assets that are located in the cloud, but we're protecting your assets with the cloud, with Checkpoint's CloudGuard within the cloud. Let me rephrase that to be sure that this is clear. We are using Checkpoint CloudGuard services to help protect customer assets that could be located anywhere, either on the premise, in the branch or headquarters, or in your data centers. So, the second category of products are sold and provided to customers who might not have the necessary local equipment to do access control and threat prevention on the premise. And so the protection and inspection are actually done with and by Checkpoint CloudGuard services that are running in the cloud. CloudGuard SaaS. This CloudGuard SaaS solution helps secure many SaaS applications such as Office 360, Microsoft Exchange, Dropbox, Salesforce, Gmail. All of these SaaS applications and many others are actually located and hosted in the cloud by the application manufacturer. These applications can be vulnerable and are exposed on a daily basis to potential breaches. CloudGuard SaaS security solutions make sure that all cloud applications are secure and protected. CloudGuard SaaS is the only security solution to prevent attacks on customers' SaaS applications and block cybercriminals from taking over your employee SaaS accounts using a unique solution such as identity protection technologies, phishing protection, data leakage prevention, and zero-day threat prevention. Checkpoint CloudGuard Connect is a cloud security platform that provides Checkpoint latest threat prevention and access control for branch offices. This CloudGuard solution helps protect your branch networks using the Checkpoint Cloud. All customer data is routed from the branch networks to the Checkpoint Cloud. From there, we do access control and threat prevention inspection. We offer the same high level of security in Checkpoint's cloud, just like traditional network security. This is also known as NAS, Network Security as a Service. The advantage here is that you don't need to purchase additional equipment to protect your branch networks. In addition, no maintenance is required by the customer. Checkpoint does all the upgrading and patching within the Checkpoint Cloud environment. CloudGuard Edge. This solution helps protect your on-premise networks using an SD-WAN appliance. SD-WAN appliances are third-party gateway appliances that have virtualization capabilities and run Checkpoint security solution in a compartmentalized VM in the SD-WAN appliance. Think of an SMB appliance which runs on a third-party vendor hardware. CloudGuard MAS. We have taken the Checkpoint Gold Standard Management Server and ported into a cloud solution. Basically, this is a smart one for the cloud. What we call CloudGuard MAS, which stands for Management as a Service. You can scale up your management station as needed as your cloud infrastructures grow. And Checkpoint will take care of the upgrading, the hotfixing, and the patching. So you always get the latest security solutions without the maintenance and downtimes. This brings us to the end of this lesson. Let's quickly recap before exiting this video. I mentioned that CloudGuard can protect your assets in the cloud, and CloudGuard can protect your assets with the cloud. To protect your assets in the cloud, we have 5 main solutions. We have the CloudGuard Network Security and Threat Prevention solution. We have the Cloud Security Posture Management. We have the Cloud Intelligence and Threat Hunting. And we have the Workload Protection and also the Workload WAP, Web Application and API Protection. Those are the 5 main solutions that protect your assets that are located in the cloud. We have another set of CloudGuard solutions that protect your assets with the cloud. We have the CloudGuard SaaS solution. We have the CloudGuard Connect solution. We have the CloudGuard Edge solution, and we have the CloudGuard MAS solution. That completes the end of our 4th lesson, and that is the end of this training video. I hope to see you in the next video. Until then, so long and goodbye. Welcome to Checkpoint Jumpstart Training Series. In this training series, we'll be looking at different Checkpoint CloudGuard product lines. Checkpoint CloudGuard is a suite of products and solutions that can secure your data and virtual networks in the cloud. In this training module, we'll examine our first CloudGuard capabilities, called the CloudGuard Private and Public Network Security. CloudGuard Network Security is used to protect both your private and public cloud network assets. My name is Manuel Joaquin, and I will be your technical trainer for this training module. But before we get started, let's take a quick look at the agenda of this training video. we're going to break this training video into separate lessons. Each lesson will be a separate video. You can view them all together in one viewing or consume them separately as needed at your own leisure. Lesson 1. CloudGuard Solutions. Here, we'll look at Checkpoint CloudGuard security solutions to secure your cloud environments. We will look at some of the CloudGuard capabilities in both the private cloud and also the public cloud environment. Lesson 2. CloudGuard Components. In this lesson, we'll take a look at the components for CloudGuard, the management station, the gateway, and now the controller. We will break these components down to give you a better perspective on how they work. And then Lesson 3, Cloud Segmentation. CloudGuard can be used to protect your cloud environments, and here we're going to discuss how to use CloudGuard to segment your cloud, to give you the ultimate protection with north, south, and east-west segmentation. Let's start this first lesson by discussing some of the CloudGuard cloud solutions. Here, we will examine CloudGuard capabilities that are used to protect both your cloud assets and your network assets. CloudGuard can be deployed in both public and private clouds. Each of these solutions has some pros and cons, but we're not going to go into detail here. But suffice to say that each cloud has some advantages. In the public cloud, you don't need to purchase any equipment, so it's cheaper to launch. In the private cloud, you own all the equipment, and so it's a more expensive upfront cost. And in turn, each cloud solution has some disadvantages. In the public cloud, your data has to be uploaded to the cloud into the public domain, so it could be accessible by anyone. So you need to make sure that you lock down the access and permissions to prevent any data leakage. In the private cloud, your data is local, which means it's a bit more secure, but you still need to make sure that you've patched any vulnerabilities to prevent any data breaches. In the public cloud, we currently support 6 cloud providers: AWS, the Amazon Web Services, Microsoft Azure Cloud, the Google Cloud Platform, Oracle Cloud, Alibaba Cloud, and IBM Cloud. All of these clouds are currently supported by Checkpoint's CloudGuard network security solutions. As far as cloud providers go, AWS dominates 40% of the market, Azure controls about 30% of the market, Google has about 20%, and the rest is split between the other cloud providers. CloudGuard not only protects public cloud environments, but also private cloud environments. There are a few types of private cloud environments, and we can classify them into two primary groups. In the first group, CloudGuard is supported on virtualization software, such as hypervisor operating systems. And in the second group, CloudGuard is also supported on software-defined networks, which can also be referred to as software-defined data centers. And in the second type, not only do we virtualize servers, virtual machines, but we can also virtualize the whole gamut of network infrastructures, like routers and switches, firewalls, and gateways. Let's break this down a little bit further. In the hypervisor methodology, CloudGuard is currently supported on a few hypervisor operating systems. We currently support CloudGuard running on VMware ESX operating system, on Microsoft Hyper-V operating system, on Linux KVM, and also on Unix. The other type of private cloud is the software-defined networks. A software-defined network can virtualize the whole network infrastructure, and CloudGuard can be installed here to protect the whole virtualized network infrastructure. On a software-defined network, CloudGuard is supported on VMware, NSX, Cisco, ACI, and also on Nokia Nodge networks. But about 84% of customers are probably running a hybrid solution, which combines both the public and private clouds. Most customers need a cloud security solution that can run in multiple environments, either on a premise, in the cloud, or in a multi-cloud, or in a hybrid cloud. That means that the security solution must offer the best security protection on the market, while at the same time, it should also be easily configurable and have a single unified management solution. CloudGuard does exactly that. It helps enforce a consistent policy throughout all environments and all assets. And it also helps in reducing operation, training, and education costs, which minimize knowledge gaps. That brings us to the end of this lesson. Let's quickly recap before exiting this video. In Lesson 1, we discussed that CloudGuard can be deployed in both the public and private clouds, and that most customers need a solution that can be deployed both in a public or a private cloud. And they also need a solution that can be easily managed when deployed in multi-clouds and in hybrid clouds environments. CloudGuard Private and Public Cloud Network Security product is such a solution. That completes our first lesson. In the next lesson, we will discuss different CloudGuard components. I'll see you there. Welcome to the Checkpoint Jumpstart training series. In this training module, we'll examine the CloudGuard capabilities called CloudGuard Private and Public Network Security. The CloudGuard Network Security is used to protect both your private and public cloud network assets. Lesson 2, CloudGuard Components. In the second lesson, we're going to go over the CloudGuard components. We're going to list each component and discuss how they function. Let's first start this lesson by discussing some of the CloudGuard cloud components. I'm going to list some new components that only function with the cloud. The CloudGuard components include the GUI client, the management station, the enforcement gateway, and now there's a new component called the controller, but more on that in a moment. Even though you might be already familiar with most of these components, let's break them down, at least from a cloud perspective. We'll start with the GUI client. Available from version R80, the GUI client has been refreshed with a new look and feel, with built-in cloud support, including API capabilities for orchestration and automation. Using RESTful APIs, you can create rules and objects with the Management API. You can add users and identities with the Identity Awareness API. You can add malware protection and threat protection with the Threat Prevention API. All of these API capabilities help automate and provision all of the checkpoint gateways. CloudGuard Gateway offers the same level of security with all the same access control solutions that you're already familiar with. We offer the firewall, the NAT, IPsec VPN, URL filtering, application control, and content control. All of these solutions can be configured in the same way just as in traditional network. CloudGuard also offers the same fully integrated advanced threat prevention solutions like IPS, antivirus, antibot, SandBlast, which is threat emulation and threat extraction. The Checkpoint Management Station is the industry's gold standard. It is used to manage all of your checkpoint gateways, enforcement points, and sensors. The Checkpoint Management Station has a few key strengths. It holds and contains a centralized database. This database stores all the objects and rules that are pushed to all relevant gateways. It is a GUI object-oriented, which means it is easy to configure and intuitive to manage. It can manage all of your checkpoint products and blades across different domains, the clouds, the networks, the endpoints, the mobile, IoT devices, and data centers. It is also backward compatible. It can manage the gateways that are running the latest version of software or gateways running older versions. On top of these components, we've added a new component called the controller, which is part of the management station. It's embedded with the management solution. The controller allows your database, policies, and rules to be adaptive and dynamically updatable. This is crucial in the dynamic nature of cloud environments. Let's look at it this way. It's the controller's job to scour and comb through your cloud environments and find objects that were added or deleted. Consequently, it updates the management station's database and the firewall's rule base. To make sure that you understand this power and flexibility, let's contrast this with traditional networks. In traditional firewalls, when you add a new server on the network, or when you need to create the server or host object, or when you add or change the IP address of a host or a network object, you need to add or change the object in a rule, or even create a new rule. Then you need to compile and push the policy to the gateway. This process can take time, and it is slow and methodical. In addition, you might be bound by the constraints of having to schedule change maintenance windows, or perhaps you're on a change freeze lockdown time frame. This traditional approach will not work with the cloud because of the cloud's dynamic nature, which renders this approach as insufficient and unacceptable. In addition, application developers upload their apps into the cloud for testing, performing tests on multiple platforms, PCs, smartphones, and on various operating systems. Developers might be in a continuous cycle of testing, recoding, and rebuilding. You may also have the operators who deploy and spin up these apps and workloads in different regions and in different clouds. This elasticity and flexibility that makes the cloud so dynamic in nature becomes impossible to manage from a traditional firewall perspective. To solve this, Check Point uses the controller, which operates with multiple cloud providers and in multiple or hybrid clouds, in multiple accounts, and in multiple regions, scanning for changes in objects within hosts, servers, or networks, including IP address reconfigurations and object deletions, and then updating and enforcing the firewall policy accordingly without a single policy push. Let's take a look at how this is accomplished. In the policy, you need to create a control connection from the management station to your cloud provider. Once you have established and authenticated a connection to the cloud provider, all network and workload objects are viewable and accessible from the Smart Console. Now, instead of using IP addresses or host names and resource names in a rule base, you can use tags. Name tags are like labels that you assign to the object, like object names, object IP addresses, object servers, users, or groups. Name tags can be created for a single asset or for multiple assets, such as workloads or virtual private networks. Once you tag an asset in the cloud, you can use the tag in the rule base. All cloud objects with the same tag name will be matched by the rule base that uses those tag names. If an object is removed, it will no longer be matched by the rule base. If an object is created and then tagged with the same tag name in the rule base, it will now be matched by that rule in the rule base. If the IP address of an object or workload changes, the controller gets notified and it changes the IP in the rule base accordingly. Change in the cloud object with a tag name will update the controller. The controller updates the management station rule base that the tag has a new name change. The management station then updates the firewall and starts enforcing the new change that has the tag name. The controller component allows us to have an adaptive management station. So when your cloud evolves, the policy can automatically adapt without needing to push a new policy. That brings us to the end of this lesson. Let's quickly recap before exiting this video. In this training module, we discussed the different CloudGuard components. We have the GUI client component, the management server component, the enforcement gateway, and now in the CloudGuard, we have a new component called the controller. The controller, its responsibility is to get the cloud identities from your cloud accounts, from your cloud service providers, and then feed these identities to the management station. And then the administrator can use these identities, these cloud identities, and use them in the policies and rule base. That completes our second lesson. In the next lesson, we're going to discuss how to use CloudGuard for segmentation. I'll see you there. Welcome to Checkpoint Jumpstart Training Series. In this training module, we will examine the CloudGuard capabilities called the CloudGuard Private and Public Network Security. CloudGuard Network Security is used to protect both your private and public cloud network assets. Lesson 3, CloudGuard Segmentation. In this third lesson, we're going to learn how to use CloudGuard firewall rule bases and some creative cloud routing to help segment your cloud networks. Now let's talk about CloudGuard segmentation. The word segmentation can have multiple meanings in network terminology, but here I'm referring to the meaning that networks are isolated from each other. So if one machine is compromised on one network, it can then compromise other machines on the same or other networks. CloudGuard can be used to protect and inspect your cloud environments in what we call a north-south virtual clouds configuration, and also between your virtual networks in what we call an east-west data flow configuration. In the next few moments, I'm going to explain what I mean and how these traffic flow configurations can be used to protect your networks. North-south segmentation refers to egress and ingress inspection perimeters, meaning here we are inspecting traffic to and from your virtual cloud environment. The North Perimeter Hub would be hosting any public cloud assets that would be public facing, and here most traffic would be leading from and to the internet. The South Hub will be hosting all your private cloud assets. These are your internal only assets, for your eyes only, so to speak. And from here, most assets would be accessible to and from your organization, head office or branch offices, and your company personal and private assets would be stored here. East-west refers to lateral traffic movement. Traffic that is moving from one cloud network to another cloud network. This can also refer to traffic movement within the cloud, from one subnet to another subnet, from one virtual private cloud to another virtual private cloud, from one availability zone to another availability zone, from one region to another region. This lateral movement would mostly be accessible and accessed within the cloud provider's backbone. No traffic would be forwarded to or from the internet. And then we would inspect traffic at different cloud and network perimeters. As traffic is flowing between different cloud perimeters or moving between your virtual networks or your virtual workloads, ideally we would have a CloudGuard gateway at each perimeter's edge. Most traditional network segmentation protects your assets from the north-south perimeters, meaning ingress and egress traffic. But what is different in the cloud is that now, with CloudGuard solutions, we can even protect both your assets from north-south and also from east-west perimeters. East-west segmentation is an additional security solution that adds an additional layer of protection into your network that you cannot do with traditional networking. But you can do this in the cloud by taking advantage of some very creative routing, which we will discuss shortly. So now let's take a look at how to segment your assets in the cloud. In this video, I'm going to focus on the public cloud. even though you can do both north-south segmentation and east-west segmentation in both public cloud solutions and also private cloud solutions. The implementation is different. The concept is the same, but how to achieve it varies between private cloud solutions. So for now, private cloud is out of the scope of this training series. Let's now first take a look at the north-south perimeter inspection. The north perimeter is your internet-facing hub. This is where you assign workloads that are accessible from the internet. Your customers will be able to get to your internet-facing assets, such as your web servers, your database servers, your marketing servers, or any other servers that you want them to be accessible from the internet for your customer base or for the general public. So you want to be extremely sure that you have the utmost protection with the highest level of security in this north perimeter. And in addition, and I have alluded to this a few times, depending on your business demands, this northbound hub can be scaled up during business peak hours or scaled down during slow downward trends. The north perimeter hub is where your internet-facing CloudGuard firewalls will be located. This is your public-facing hub, and this is where you protect your assets that are accessible from the internet. Here is where you define your access control rules, your users' identity permissions to your public cloud assets, and here is also where we inspect traffic with threat prevention blades to prevent breaches into your cloud networks. For obvious reasons, no northbound traffic should have access permissions to your cloud infrastructure. They might have only access to your public-facing data, your web servers, your databases, but you want to be sure that there is no access to your cloud infrastructure. And this includes load balancers, firewalls, gateways, workloads, and so only approved protocols, services, and applications would be allowed. And this is true for any network, be it public, private, cloud, or traditional networks. And of course, all other unapproved protocols would be dropped at the perimeter, and so only access to the data on the servers will be allowed, and any access to the servers themselves would be dropped, like RDP connections, for example. Now let's take a look at the South Hub. Here is where most customers create what we call a southbound perimeter. This perimeter, in general, will not be public internet-facing assets, and so it would not be allowing traffic from the general public, but instead, even though these assets are still stored in the cloud, these would be assets that should only be accessible from and to the organization. These are company-facing assets, assets that would be accessible from the many of the company's various locations, different locations such as the headquarters, branch offices, or the company's data centers. And they may be also accessible from and to other cloud regions or other cloud providers. All data leaving to and from this location would usually be encrypted through a native IPsec VPN or other encryption solution. And so for security reasons, only traffic sourced from the headquarters or sourced from the branch offices will be accessible through the southbound perimeter. Traffic could still be outbound to the internet, but mostly it would be for software update or software patching. And so you would still need CloudGuard Firewall located at the southbound perimeter to either accept authorized traffic, but obviously you would need to block any nefarious security breaching attempts. Again, let me repeat, so we can understand clearly the difference between the North Hub and the South Hub. In the North Hub, we have public-facing assets, assets that we want to be available to the general public. In the South Hub, this is where you would store your private and confidential assets. No public-facing or customer traffic is allowed through the South Hub. Only private traffic to and from your organization is allowed. You might also allow outbound software updates, but no source traffic from the internet would be allowed through this southbound hub. So here, you would place a southbound facing CloudGuard firewall and only allow traffic sourced from your locations. Any traffic sourced from the internet would be dropped here. Now let's talk about east-west segmentation, which is completely different between north-south segmentation. The main purpose of east-west segmentation is to protect your assets in the cloud, in case an asset or workload has been compromised. In traditional network, once an asset has been compromised, then all bets are off. Once an asset has been compromised, then the attackers will be able to spread and infect laterally between host to host. The same is true also in the cloud. Once an asset has been compromised in the cloud, attackers are able to spread laterally from virtual machine to virtual machine, or perhaps even extending their reach into the corporate networks. But in the cloud, we can add another additional security protection, what we call east-west segmentation. With east-west segmentation, when a host tries to communicate to another host on the same private cloud, it cannot do so directly. It first needs to go through the CloudGuard gateway for access permissions and threat inspection. If it is accepted, then the traffic is allowed. And even if the hosts are directly and physically next to each other in the same subnet, we can still prevent lateral movement in what we call the east-west traffic flow to secure the cloud assets. This is also what we usually call micro-segmentation. The workloads can be directly connected to each other, and still all traffic flow must first go through the CloudGuard gateway for approval, for access control permissions, and also threat prevention inspection before routing to its final destination. As mentioned already, this kind of segmentation is not possible in traditional networks. This is only possible in the cloud. So how do we do this? Again, I'll repeat to be sure this is clear. We take advantage of special native cloud routing rules and creatively segment the workloads. So even though the workloads might be on the same network, we're using very creative routing solutions to make sure that when the workloads need to communicate to any other workload on the same network, the traffic first needs to be routed to the CloudGuard gateway. For a complete rule-based analysis that defines what workload traffic is allowed and to what other workload and protocols are allowed, and in addition, the CloudGuard will perform deep packet inspection to make sure the traffic is benign and legitimate before routing the traffic to the destination workloads. Notice that in this diagram that even though host A and host B are on the same subnet, they cannot directly communicate with each other. That's because we created a routing entry in the routing table that says that the next hop is the CloudGuard gateway. So the source is host A, the destination is host B, but the next hop is the CloudGuard gateway. I'll show you how to exactly do this in the lab section of this training series. That brings us to the end of this lesson. Let's quickly recap before exiting this video. Lesson 3 was about CloudGuard segmentation. In this training module, we discussed how to do cloud network segmentation. In this lesson, we learned that we can secure traffic in the cloud using what we call segmentation. And we have a few kinds of segmentation. We have what we call the north-south segmentation, which helps direct and secure the traffic flow to and from the internet and also to the corporate offices. We also have a different kind of segmentation, what we call east-west traffic flow segmentation. And here we can segment traffic to prevent lateral infection, even though the workloads might be directly next to each other. We use creative cloud routing solutions and firewall rule bases to segment and protect the cloud assets. That completes our third lesson, and that is the end of this training video. I hope to see you in the next video. Until then, so long and goodbye. Welcome to Checkpoint Jumpstart Training Series. In this training series, we'll be looking at different Checkpoint CloudGuard product lines. Checkpoint CloudGuard is a suite of products and solutions that can secure your data and virtual networks in the cloud. My name is Manuel Joaquin, and I will be your technical trainer for this training module. I would like now to show you a demonstration of CloudGuard and how to deploy it in the cloud environment. In this lab, we're going to deploy a Microsoft Azure cloud environment. But I'm going to make some basic assumptions. I'm going to assume that you have some basic knowledge of Checkpoint products and know how to configure a standard management station and a traditional Checkpoint gateway, and that you're here to learn how to deploy it in the cloud. And also, I'm going to assume that you're new to the cloud, and so I'm going to primarily focus on what is new or different with a cloud deployment, what is different between the regular gateway and the cloud gateway. But first, let me give you a big picture overview of the lab. In this lab, we're going to deploy one VNet, 3 subnets, a management station, a gateway, and a web server. We're going to launch and interconnect all the components and to create a firewall policy and rules to make it all function and connect to the internet. We're going to break down this lab into small steps. These steps will be broken down into 5 separate exercises. I'm going to walk you through step by step on how to deploy a CloudGuard gateway into the cloud. And you can also come back and reference these separate exercises as needed during your own CloudGuard deployment journey. Let's get started with the first exercise. Exercise 1. How to build an Azure private cloud environment. In this first exercise, we're going to deploy a VNet, the virtual network, in Microsoft Azure, which will be automatically connected to the internet. After building our virtual network, you cannot just add virtual machines to the virtual network. You must first configure your subnets. And then within your subnets, you can then add your virtual machines. In total in this lab, we're going to configure 3 separate subnets. But at the minimum, when deploying a CloudGuard, you need to have 2 subnets. And this is by design for optimal CloudGuard deployment. And I'll explain why as we progress. Once we have created VNet, we will then create our first subnet. We will call it the front-end subnet. The second subnet, we will call it the back-end subnet. This is going to be our first lab. Let me show you how to do this. Connect to your Azure account, go to the main launch menu, and then go to your virtual networks. We're going to create our first virtual network, our first virtual private cloud. Let's select Create Virtual Network. We need to fill in the fields as follows. The subscription, I only have 1 subscription in my account, so we'll leave it as is. The resource group, in my account, I have a few resources already created for me. I'm going to select the first one, but depending on your subscription and your account, you might need to create a new resource group. My account permissions do not allow me to create a new resource group, so I will need to select one of these pre-built-in ones. Now for the name, what do you want to call your virtual network? You can be as creative as you like. I'm going to call mine my VNet to keep it simple. I will keep the region as the default. That works for me, but you can select whichever region you're in, or better yet, what region your customer base is in. Let's go to the next screen. You just need to click on the next field, IP addressing. Here, we're going to define the network address range for the virtual network. You can select whatever address range that you like. This is going to be a private range. It should not be accessible from the internet, at least not now. Again, I'm going to keep the defaults. 10.0.0.0/16, which is a Class B network. This will give me a really big, wide range to create my subnets in. Now I need to create a subnet so I can place my VMs in it. The default is fine, but I want to change the name. I will change the name to front end. You'll see why later. I will keep the default subnet, which is a /24. 10.0.0.0/24 is the subnet of my VPC range of /16. Let's select Save. Now I want to create a second subnet, so let's select Add Subnet. This second subnet, I'm going to call it the back-end subnet to differentiate it from the front-end subnet. I will again use a /24, which is within my /16 VPC range, 10.0.1.0/24. Again, we select Save. Let's move forward to the next screen, select Security. We'll keep the security settings the same. No changes are required here. Let's move to the next screen, select Tags. I'm not going to put any tags right now, but I could if I wanted to. The tags can be used to search for this resource later during the rule-based creation and deployment. But for now, let's just select Next. Review and create. The Azure software will verify that all my selections are copacetic and that nothing is wrong. If there was any mistakes, I will need to correct them now. If everything is fine, I just need to select Create. The Azure server will now create my virtual network, my 2 subnets under my account and subscription in my region of choice. Let's select the deployment icon. It tells me that the deployment is in progress and I just have to wait for it to complete. In this case, it is fast and the deployment is completed quickly. Let's select Go to Resource to see what we have created. So we created a VPC called My VNet. Then, if you go to the Subnet tab, we will see the 2 subnets that I have created inside my VNet VPC. We have the front-end subnet and the back-end subnet. The front-end subnet is 10.0.0.0/24 and the backup subnet is 10.0.1.0/24. To recap, we created a VNet 10.0.0.0/16 in the Azure environment. We then created inside this VNet 2 subnets. The first subnet, we call it the front end with a network of 10.0.0/24, and we created a backend subnet with a range of 10.0.1.0/24. That completes the end of exercise 1. In the next exercises, we will populate the subnets with virtual machines. I'll see you there. Welcome to the Jumpstart CloudGuard Deployment Lab. In your previous exercise, we deployed an Azure virtual network with 2 subnets. That was done in preparation to set up a CloudGuard gateway. In this second exercise, we're going to deploy a checkpoint management station. The management station could be deployed in various locations: at the customer premise, in another VPC, or another cloud environment. But to show you the scope of CloudGuard, we're going to deploy the management station also in this Azure cloud within the same VNet. We're going to place the management station in the front-end subnet. Let me show you how to deploy it in the front-end subnet of your VPC. Let's get started. Again, connect to your Azure account. There are a few ways to deploy it. Go to the home menu and select Create a Resource. In the marketplace, you can search for the product that you want. In this case, we're going to type CloudGuard, then we hit the Enter key to search through the marketplace. We find 2 products with that name. The search results shows us the CloudGuard Network Security, Firewall, and Turret Prevention product. Let's select this product. If this is your first time installing this product, I suggest you spend a few moments to review it. You can read a little bit about this product if you like, regarding some of the benefits, deployment plans, and also some of the support information. I covered most of this already in the previous video, but it might be a nice refresher. Now let's take a look at the plans that you can deploy. Select the pull-down menu. Checkpoint offers 5 different deployment plans. They can be grouped into 2 categories. We have the management station and the gateway. In the management station, we have 2 kinds of deployments. We have the standard single checkpoint security management, and we also have the CloudGuard multi-domain server, which are for large enterprises. In the gateway category, we have the single gateway and also a cluster high availability solution that offers resiliency and redundancy. And third, and finally, we offer the CloudGuard Scale Set solution, which is for dynamic and scalable platform solutions that can scale up and down as your business demands needs increase and decrease. In this exercise, we will install the Checkpoint Security Management. So make sure you select it and then hit Create. We now need to fill the fields as follows. The subscription stays the same. The resource group has to be a new one that does not have any resources attached to it. Notice the error when I select the first one. That's because we already used that in the first exercise. It has already been assigned to my VNet and the subnets. So let's select the second one in my case. But in your case, if your accounts and subscription permissions are different, you might need to create a new one. We will keep the region the same, East US. You can select your region, the same region that you selected in the first exercise. Now we need to give this a server name. I will call mine CPMNG, which is short for Checkpoint Management Server. Now we need to define a password. This is the Gaia Smart Console login password. There are special security requirements that your password must meet. The password must not include reserved words or unsupported characters. The password must be a minimum of 12 characters or longer. And the password must contain 3 of the following: either 1 lowercase character, 1 uppercase character, 1 number, or a special character. The more complex, the better. But obviously, it should be something that you will be able to remember, and you will need to retype it a few times, every time when logging into the management station. You need to confirm your password. This is a nice sanity check. All software do this now. Select Next to change the Checkpoint Security Management Server settings. We're going to make a few modifications from the default. Let's select R80.40 version. For the license, we will select the pay-as-you-go license. It will give us a 30-day eval license, and it is also the cheaper one to test with. The virtual machine size, we will keep the defaults. There is no need to change it. And also, it has been optimized to work with CloudGuard. The installation type is Management Station. Allowed clients, we will leave it as is for now. But it would be best to lock this down to your GUI client's network or IP address. The rest will keep the defaults. And now let's hit Next for network settings. We are going to place this CloudGuard Management Station. We're going to select the VPC that we created in exercise 1, my VNet. And we are going to attach it to the front-end subnet that we created in exercise 1. Select Next to review and create. The Azure software will verify that all your changes are fine. If we forgot anything, we would get an error and be prompted to fix any discrepancies. Okay, we got validation passed. This is our green light to continue. Let's select Create. The Azure software will now deploy our new CloudGuard Management Station in my account, within my subscription, in the US region, in my VNet virtual network. and we'll attach it to the front-end subnet. This deployment can take a few minutes. I am going to fast forward to the completion. Notice some of the resources that it is creating. Notice that we never added an IP address. It's going to use the first IP address in the front-end subnet. Now the deployment is completed, at least from the Azure interface perspective, but in the background it is still installing and configuring the Gaia and Checkpoint software. Let's select Go to Resource. I am looking for the IP address. We need to select the resource of CP Management Virtual Machine. Let's click on it. In the Overview page, notice that there is two IP addresses, a private IP address and a public IP address. Notice that it added a public IP address. The public IP is the routable IP. Microsoft Azure gives it to you when you deploy the resources in their cloud. So your virtual machines resources will be accessible from the internet. Let's select Copy IP Address, and now let's open a browser and connect to the public IP address, https://1382.196.207, or whatever IP address that has been provided to you. Hit enter. We get the standard certificate, cannot be verified, which is normal because it's a self-signed certificate. Select Proceed to continue. Great, we get the Gaia browser login page. We need to provide the username and password. This is the password that we created before in the deployment step. Select the logon icon. Notice we got a message that the system is still being configured. Please try again later. We have to wait a few more minutes. Even though we have deployed the management on Azure Cloud, the operating system is still being hardened and the Checkpoint software is being configured. This is the longest time to wait. But we can take a look at the Azure console to see what is going on. Scroll to the Serial Console, which is a new feature in Azure. It takes a few moments to connect. You can see that it's still booting. Let's time-lapse this forward. Still not ready. 8 minutes later, there we go. We have the Gaia portal access. The management station is now fully loaded. From here, we can download the Smart Console. Select Download Now. Let's quickly take a look at a few things while we are here. Let's go to the Network Interface tab. Notice that even though we never entered an IP address during the deployment, two IP addresses have been configured. There is a private IP address, 10.0.0.4, on ETH0. This is the first IP address in the front-end subnet. That we gave it a range of 10.0.0.0/24. Remember, our VPC was a /16. So the /24 was a subnet range for the front end. So it selected the first available IP in the /24 range. .0 is reserved for the network, which is the same in traditional networks. .1 is reserved for the gateway. The gateway is implied in Microsoft Azure. You don't need to create it. It automatically, implicitly gets created for you. .2 and .3 are also reserved for the Azure Fabric. So .4 is the first available IP. 10.0.0.4 is the Checkpoint Management Station IP. Notice that it also created an alias on ETH0:1. with the public IP address. This is the IP that we're using in the browser. Now let's take a look at the static routes. Notice the default route. In Microsoft Azure, you don't explicitly create the default gateway. It is implicitly created for you when you define the subnet. In this case, the front-end subnet. 10.0.0.1, this is the first IP in our /24 front-end subnet range. Even though we never created an explicit gateway with this IP address, all routing will be sent to this gateway IP, which sits within the Azure Fabric, and all routing will be done by and through the Azure Fabric. The other two routes were created by the Azure, and they will be used by the Azure software and are not relevant to us now. Now, let's open a PuTTY session to the management station. I need to run some commands and also show you the status. Again, we need to log in with our admin username and password. Alright, we're in. Two things. First, we are going to enable CloudGuard with the command CloudGuard on. You need to run this command to make sure it is a CloudGuard management station, or else it is just a standard management station. I will show you that in a moment. CloudGuard IaaS is successfully enabled. CloudGuard IaaS is the code name for CloudGuard Network Security and Threat Prevention product. The second command that I'm going to run is just to show you what the first command did. cpwd_admin space list shows us the checkpoint processes that are running. The command CloudGuard on has started the CloudGuard process, which is the controller process. So this VM is a management station, but it's also a controller, which will make adaptive security easy, as explained before in the explanation video. Smart Console has finished downloading. You can now start the installation of Smart Console. For time constraints, I will skip the installation details in this video. I assume you have done it before. If not, just accept all the default settings. Once Smart Console is installed, let's launch it, and now we need to log in. Again, we provide the username and password, and also the IP address of the management station. Select Proceed to accept the fingerprint. Connecting, initializing, launching, almost there. We have liftoff. Now you can browse through the console to get a feel for it. If this is the first time viewing R80.40, I will let you explore it on your own. Before ending this video, let's just recap what we did in this lab. In exercise 2, we deployed a CloudGuard management station. We deployed the management station in our Azure virtual network called MyVNet. We attached the management station directly to the front-end subnet 10.0.0.0/24. The Azure software assigned an IP address of 10.0.0.4/24, which is the first IP address in the front-end subnet range. The Azure software also assigned us a public IP address, which will be routable from the internet. In my case, it assigned it an IP of 13.82.196.207. The Azure software also deployed an implied gateway of 10.0.0.1. This is the default gateway for my VNet virtual network. After installing the management station, we turn on the controller process with the command CloudGuard on. We also downloaded and installed the Smart Console client on my Office PC. After the management station was fully installed, we then connected through Smart Console from the Office to the Azure Cloud. This now concludes the end of exercise 2. In the next exercise, we're going to deploy the CloudGuard Gateway. I'll see you there. Welcome to the Checkpoint Jumpstart training. How to deploy a CloudGuard Network Security and Threat Prevention Product Lab. Exercise 3. How to deploy a CloudGuard Gateway. In the previous exercise, we deployed a CloudGuard Management Station on our VPC and attached it to the front-end subnet. In this third exercise, we're going to deploy a CloudGuard Gateway. And we are going to place it in between the front end and the back end subnet. Meaning that it will have one NIC attached to the front end subnet and another NIC attached to the back end subnet. And finally, we're going to establish SIC and then configure and push a policy. Let's get started. Again, connect to your Azure account. Go to the Home menu and select Create a Resource. This will take you to the Marketplace search bar. Here we type Checkpoint. We get a few firewalls that pop up, but we want to install the CloudGuard. So select it. Again, this is the same product as before, and we have 3 types of firewalls that we can deploy. We have the single gateway, we have the high availability solution, and we also have the highly scalable CloudGuard scale set. We're going to keep it simple in this lab, so let's select the CloudGuard single gateway. Click Create. OK. We need to add some basic configurations. The subscription we will keep the same. For the resource group, we need to select an unused resource group. The first 2 we have already used, so we cannot use them. We get an error that they are being used. So let's select the third one in my list. Again, depending on your account permissions, you might need to create a completely new resource group. We will keep the region the same, like always, East US. For the virtual machine name, I will use CPI GW. Let's enter a password. I will use the same password that I used before on the management station. This makes administering both machines easier. Again, we have to meet the same password restrictions, just like before. We need to confirm the password, and we need to be sure that they match. Once again, we get a green icon, so we're good to go. Select Next to proceed to configure the Checkpoint CloudGuard settings. Again, we're going to select the R80.40 Gateway version. One more time, select the pay-as-you-go license. We'll keep the default VM size. Installation type is Gateway only. Now we need to add the SIC key. The SIC key is like a password that will be used to build trust between the management station and the gateway. It is used to build a secure communication channel over an SSL link. All internal communication will be encrypted using this SSL link. We need to confirm the SIG key. Select Next to configure the network settings. We will add this gateway to my VNet virtual network. The gateway will need to be hooked up to two networks. On the front side, we select the front-end subnet that we used before, the 10.0.0.0/24. On the back side, we select the back-end subnet that we created, the 10.0.1.0/24. Finally, let's now select Review and Create. The verification will verify that all the information that we entered is correct. Oops, notice that it found an issue. Let's take a look. There is an asterisk on the Checkpoint CloudGuard settings page. Let's take a look there. Found the problem. The SIG password did not match. Let's fix and confirm that. We get a green icon, so we are good to go. Let's review and create one more time. Perfect. The verification is complete and we're good to create. Hit Create. It's now deploying a CloudGuard gateway, and this step can take a while. For time constraints, I will fast forward to the end of the completion stage. A few minutes have elapsed to complete the gateway deployment. Let's select Go to Resource. Let's select the virtual machine resource, the CGI Gateway Virtual Machine. Again, I want to check that IP address. Just as before, we never specified an IP address. The Azure software will add a private IP address and a public IP address. Let's select Copy Public IP Address. Let's open a browser tab and connect to the gateway. https://23.101.141.87. Let's proceed to continue. Nice. We get the Gaia login page. So far so good. Let's log in, enter the username and password. We're in. The gateway is up and running. Let's once again take a look at a few things while we are here. Let's go to the network interfaces. We have 3 IP addresses. ETH0 has a 10.0.0.5. This is the second IP in the front-end subnet. Remember that .4 is the management station IP. So .5 is the next available IP address. Then the Azure software also created an alias, ETH0:1 with a public IP of 23.101.141.87. And the third IP address is on ETH1, which is connected to the backend subnet, 10.0.1.4. Again, this is the first IP in the backend subnet. Let's take a look at the routes. We have, again, the default gateway of 10.0.0.1, which is the implied gateway that Azure creates for us. I will use this gateway as the path of last resort. Everything looks good. Let's move on to the next step. we're going to establish SIC and push a policy. Let's open the Smart Console to the management station. Connecting, initializing, loading, launching. Good, we have Smart Console access. Let's select the Gateway and Server tab and select the Create icon. We'll create a new gateway. Let's use the Wizard mode, but you can also use the Classic mode if you like. We need to add the gateway name CGI GW. We need to select the gateway type. In this case, it's CloudGuard IaaS with IP address of 10.0.0.5, which is the private IP on the front-end subnet. This will be the IP address that the management station will be using to connect to the gateway, because they are on the same network. Now we need to enter the SIC activation key, which is the SIC password that we used during the deployment stage. Hit enter. Trust is established since we got the pop-up interface page. Uncheck the Edit Gateway Properties box for now. We will make changes later. Select Finish. The gateway object is completed. Now we'll need to create and push out a policy. Select the Security Policy tab. We will just change the cleanup rule to allow all traffic. Change the action to accept and track to log. Select Installation Policy icon. Confirm by selecting Publish and Install. Policy is being published. Uncheck the Threat Prevention checkmark. We won't be configuring Threat Prevention policy in this lab. Then select Install. Policy is now installing. I like to view the details. Policy installation is completed. Let's close this box. Let's go now to the Logs and Monitoring tab. We want to check and see if we have logging communication. We have logs. Notice that the log's origin is from the gateway, CGI GW. We have success. Before exiting this lab, let's recap Exercise 3. In this lab, we deployed the Nazar CloudGuard gateway. We deployed a gateway in between our two subnets, the front end and the back end. In the front end, we received an IP address of 10.0.0.5/24. And in the back end subnet, we received an IP of 10.0.1.4/24. The Azure software also provided us with a public IP address of 23.101.141.87. We then opened a Smart Console to the management station. We then established SIC between the management station and the gateway, and we pushed a simple any policy. That completes the end of Exercise 3. In the next exercise, we will deploy a web server. I'll see you there. Welcome to the Checkpoint Jumpstart training. How to deploy a CloudGuard Network Security and Threat Prevention Product Lab. Exercise 4, Part 1. How to deploy a web server. In the previous exercise, we deployed a CloudGuard gateway, and we attached it in between the front-end subnet and the back-end subnet. In this fourth exercise, we're going to deploy a third subnet and install and deploy a web server on this subnet. Then we will configure a firewall policy, a NAT rule base, to be able to communicate to this web server from the internet. Also, we're going to need to configure routes on the virtual network, routes that will forward all traffic to and from the web server, to pass through and be inspected by the CloudGuard gateway. Let me show you how to do this. Let's get started. Let's first create the third subnet. Go to the launch menu and then scroll down to the virtual network. Let's click on that. I only have one virtual network in my deployment, my VNet virtual network that we created in exercise 1. Let's open that. Then go to the subnet subtab. Here we see two subnets that we created before. We have the front-end subnet and the back-end subnet. Remember, the management station is attached to the front-end subnet, and the firewall is attached to both the front-end and the back-end subnet. I want to create an additional subnet, so let's click on Add a Subnet. Now, we need to add details about this subnet. The name, let's call it the web-net. The address range, notice that automatically it added the next available address range in the /24 subnet. We'll keep this suggestion of 10.0.2.0/24. Let's select OK. The deployment is now in progress. The deployment is completed. That was fast. Let's hit the refresh button. There we go. The web-net is created. Next, I want to create a routing table and then add routes to it. First, let's create the routing table. Go to your home menu and select Create a Resource, which takes us to the marketplace. Let's search for route. We want the route table. Okay, let's select Create Route Table. Let's add the details. The subscription is the same. Resource group, I will pick the first one. Region, we will keep the same US East region. But in your case, you might need to change it to your region. Okay, name, what do I want to call the route table? Let's call it my VNet routes. Select Next. We get the tabs menu. Not going to tag anything now, but you could if you like. Let's hit Review and Create. Validation is complete. Let's select Create. This will go fast. Deployment is in progress. Deployment has completed. Let's go to Resource. We have the route table, but notice that there is no routes. All we did was create a route table. Now let's add some routes. Let's go to the Route submenu, hit Enter, select Add to add routes. We need to give our first route a name. Intra_VNet. This route is for all the machines that are part of my VNet virtual network. We need to add the route prefix 10.0.0.0/16. So all routes that are going to my VNet. Where do I want to send them to? Next hop type. We need to select the virtual appliance. The virtual appliance is our CloudGuard gateway. Let's add the CloudGuard gateway IP address 10.0.1.4. Remember, this is the IP that the gateway received from the backend subnet. So this route says that anything that is going to a destination network that falls within the 10.0.0.0/16 range, send the packet to the virtual appliance with IP of 10.0.1.4. Let's accept that and select OK. I want to add two other routes. Select Add one more time. For a second route, again, I need to give it a name. Let's call it the default GW. This will be the route for the default path of last resort. Address prefix will be 0.0.0.0/0 if you go to any IP period. Where do we send it to? Again, we need to select the virtual appliance. This is our CloudGuard gateway with the IP address of 10.0.1.4. This route basically says send all traffic to the gateway, unless you have a specific route, which are what the other routes are for. Again, select OK to continue. The route is being added in the background. The route is complete. Now we have two routes in this routing table. We will add a third route. Again, select Add. This route is for micro segmentation for the web network. So let's call it that. Micro segmentation -subnet -10.0.2.0. The address prefix is 10.0.2.0/24. The next hop is the gateway once again, which is what Azure calls the virtual appliance. And the next hop address, and I think you get the hang of this, is 10.0.1.4. So this route says there might be multiple hosts in the same subnet, the web net subnet. These hosts do not talk directly to each other. All traffic must first go to the CloudGuard gateway for access, permission, and inspection. If it is accepted, then the traffic is routed to its destination, even though the destination might be on the same network. It still needs to go to the CloudGuard gateway. Micro-segmentation is a very powerful security weapon. By taking advantage of some very creative routing cloud capabilities. Select OK to continue. Deploying. Route successfully added. Okay, so now I have added 3 routes to my VNet routing table. But this routing table is not attached to any subnets, and so it's not being enforced by any network. So that is what we're going to do next. Select subnets. Notice that this route table is not associated to any subnets. It is blank. So let's select Associate. What subnet should we associate to this routing table? Remember, the micro-segmentation route is for the network of 10.0.2.0. So let's select the My VNet virtual network. And now let's select the web-net subnet. It's saving a route. Route is saved. So now this route table is associated to the web-net subnet. Let's now go to the Overview tab. Notice that we have 3 routes and 1 subnet. Before exiting, let's recap once again. We created the third subnet called WebNet with a range of 10.0.2.0/24, which falls within my VNet VPC range. We created a routing table called my route table. We added 3 routes to this route table, which all point to the CloudGuard gateway, the virtual appliance. Default of 0.0.0.0/0 with the next hop of 10.0.1.4. Enter VNet of 10.0.0.0/16 via next hop of 10.0.1.4. Micro segmentation route 10.0.2.0/24 via next hop of 10.0.1.4. We then associated this route table to the VNet subnet. This completes the end of exercise 4, part 1. In part 2 of exercise 4, we're going to create a web virtual machine and then add it to the WebNet subnet. I will see you there. Welcome to the Checkpoint Jumpstart training. How to deploy a CloudGuard network security and threat prevention product lab. Exercise 4. How to deploy a web server. In the previous exercise, we created the third subnet called WebNet with a range of 10.0.2.0/24. We created a routing table called My Route Table. We added 3 routes to this route table, which all point to the CloudGuard gateway, the virtual appliance. We then associated this route table to the VNet subnet. In this fourth exercise, we're going to deploy and install a web server on this subnet. Then we will configure a firewall policy and NAT rule base to be able to communicate to this web server from the internet. So how do I create this Linux virtual machine? Let me show you how to do this. Let's get started. Again, go to your home menu, select Create a Resource. In the Marketplace, search for Bitnami NGINX. Here, we are looking for a simple and cheap Linux server to deploy in our WebNet subnet. We have a few choices. Let's select the first one. Select it and then hit Create. Again, we need to define a few parameters. Subscription is the same as always in my account. We will pick the first resource group. Machine name, let's call it WebVM. Keep the East US region. We keep the image and image size as is. Let's change the authentication type to password. For the username, we'll use webadmin. And I will use the same password as before. And also confirm the password. Select Next for disks. No need to change the disk sizes. Select Next for networking. Here we will make a few changes. Let's select the WebNet subnet. This is where I want to place the virtual machine. Public IP address, we will select none. We don't want a public IP to be bound to the web server. You will see why later. Next, for management, we'll keep the defaults. Next, for advanced. Next, for tags. Next, for review and create. We need to define an email and phone number. You can put whatever you like here. A real email, in my case, I will just add anything here to get past this stage. Let's hit create. It's now deploying. This can take a while. Deployment is in progress. Fast forward. A few minutes have elapsed. The deployment is complete. Select Go to Resource. We now have created a web virtual machine. Notice the private IP of 10.0.2.4. We don't have a public IP address. That's because we selected none during the deployment. And the reason for that is that I want to use the firewall to protect this virtual machine. Let's scroll down to the effective routes. Notice we have 5 routes. 2 are invalid routes. These are the system-defined routes. They are no longer valid because they have been superseded by the user-defined routes. These are the routes that we created. The user-defined routes are the routes that we created. See, we have 3 user-defined routes. These are the routes from the routing table that we created earlier. This web server or virtual machine inherited these routes from the My VNet route table. Because this virtual machine is part of the WebNet subnet that we associated to the My VNet route table. We have the default route, we have the inter VNet route, and we have the micro-segmentation route. All these routes are pointing to the virtual appliance, the CloudGuard gateway of 10.0.1.4. Now that we have the web virtual machine created with the proper routes, we want to create a policy and a rule to allow communication through the firewall to the web virtual machine. Again, let's open Smart Console. Log in to the management station. I am logging in from my office PC to the management station that is running in the Azure cloud in my VNet virtual network in the front-end subnet. Now I want to create firewall rules to allow traffic from the office to the web virtual machine on the WebNet subnet. But first, let's disable anti-spoofing. Let's open the CloudGuard gateway. Select Network Management tab. Edit ETH0 interface by double-clicking it. Select the Modify tab. And now disable Perform Anti-Spoofing checkbox. Select OK button. Select OK again. Let's do the same thing for ETH1. Select Modify. Again, uncheck Perform Anti-Spoofing checkbox. In addition, we will select the override button and select that specific button. Now select New Network. Let's call this network object all_my VNet. Network address is 10.0.0.0/16, which is a mask of 255.255.0.0. Select OK, and OK again, one more OK, and a final OK. Select the Security Policy menu tab. Now we're going to add a rule above. Select the Add Rule Above tab. Let's call this rule Traffic to the Web Server. We will keep the source as any. We will change the destination to a new host. Let's call this host CGI GW_frontend with IP address of 10.0.0.5. Remember, that's the firewall's IP address in the front-end subnet. This host object will represent traffic that is destined to the firewall front-end IP address. Select OK. We get a message warning that multiple hosts have the same IP address. That's fine. Let's say yes to approve. This is not a conflict. It is just a warning. Let's change the service to HTTP. Action to accept and track to log. Let's add another rule below this rule. This rule is going to allow SSH communication. Name it SSH to everywhere. Source and destination is any. The service is SSH. Action is accept. Tracking is log. Now let's go to the NAT rule base. We are going to add NAT rules to allow communication to the web virtual machine. Select Add Rule to the top. This is the default NAT rule. Let's change it. We are going to make a few changes on the original side of the NAT rule base. In the original source, we're going to select the All Internet object. In the original destination, we're going to add the CGI GW_frontend object that we created before. We're going to change the original service to HTTP. On the translated NAT side, the source is going to be original. The destination is going to be the web virtual machine. Let's create a new host object to represent the web server. Let's call it my web. The IP address is 10.0.2.4. Let's OK that. The translated service, we will keep it original. Basically, this is what we call a port mapping rule. All HTTP traffic that is destined to the firewall's IP address of 10.0.0.5 will be redirected or NATed to the destination of the web server 10.0.2.4. Let's go ahead and install this policy. Let's approve to publish and install. Let's now push the policy. Again, double check that threat prevention is unchecked. Hit install. Let's view the details. I always like to see the progress bar. 57% completed. Installation is in progress. 99% completed. We can ignore the anti-spoofing warnings. because we purposely turned them off. This is more of a warning than an error. Installation has succeeded. Let's close this. Now we're going to test access to the web server. First, we need the IP address of the firewall. Select CGI GW. What is the public IP address? Let's copy that. Now we open a browser tab. Now we HTTP. We don't HTTPS. We only use HTTP. HTTPS is the firewall Gaia page. HTTP traffic will be redirected to the web server. http://23.101.141.87. Bingo! Congratulations! We have access to the web server. Let's go back and take a look at the logs. Let's refresh and take a look at only today's logs. I'm looking for the service of HTTP. Here's one. Let's double click it. Notice the service is HTTP. The destination is the CGI Gateway front end 10.0.0.5. And on a NAT, XLate means the translate side. We see the destination of my web object with IP of 10.0.2.4. This completes the end of this exercise. Before exiting, let's recap once again. In exercise 4, we did a few things. We then created a Linux web server and deployed it in the web network. After, we created firewall policies and NAT rules to allow communication from the internet to the web server. I then opened a browser from the office on HTTP and connected to the firewall public IP of 23.101.141.87. We then got redirected to the firewall private IP of 10.0.0.5. Then the firewall port mapped HTTP to the NATed IP of the web server of 10.0.2.4. This completes the end of exercise 4. In the next exercise, we're going to configure the management controller process to communicate to the Azure cloud with my VNet virtual network. I will see you there. Welcome to the Checkpoint Jumpstart training. How to deploy a CloudGuard network security and threat prevention product lab. Exercise 5. Connecting the CloudGuard controller. In the previous exercise, we deployed a web server in the web network. We created a route table and we added 3 routes. We then created a firewall policy and NAT rule base to be able to access the web server. In this 5th and final exercise, we're going to activate the CloudGuard controller on the management station. Once we have activated the CloudGuard controller, we are going to import the Azure Cloud resources into the management station so that we can then use the cloud resources, the cloud identities, and the firewall rule base. Let me show you how. Let's get started. Open the Smart Console. Go to the Object menu. Select a new host. Let's call this host localhost. It's going to represent the management station. We're going to use the IP address of the loopback which is 127.0.0.1. Select OK. Now let's go and select the gateway object of CGI GW, the Firewall CloudGuard object. Here we want to enable the Identity Awareness Blade, which the firewall will use to get the identities from the management station. So let's select this option. The deployment wizard will pop up. I really don't want the wizard, but we need to select something to get past this wizard. So let's select something. Let's select the terminal server and uncheck the AD query option. Select next. Select I don't want to configure Active Directory. Select next. Now let's finish. The reason I went through the wizard is to get the Identity Awareness tab. So let's select it. As I mentioned, I really did not need the terminal server. I only selected it to get past the wizard. So now let's uncheck it. What I really wanted to enable was the Identity Web API, but it was not an option during the wizard. So let's select it now. We also need to configure some setting parameters. So select Settings. Select the green icon to add a client. Now let's select the localhost object that we just created. Select OK and select OK again. Say yes to accept the URL change. Again, select yes. You want to keep the change that multiple objects have the same IP address. Now let's install the policy. Then publish and install. It's publishing the changes to the management station. Now let's install the policy to the firewall. Let's view the details. Now it's installing the new policy to the firewall. This new policy will turn on the identity awareness process on the gateway. We're almost there. Policy push is complete. Let's close this. The identity awareness process is now set up and ready to get the cloud identities from the management station using the Identity Awareness API. The controller process that is running on the management station will get its identities from the Azure cloud using the cloud APIs. Remember, we turned on the CloudGuard controller on a management station in Lab 2. But we never really configured the controller. So how does the management station get the identities from the Azure cloud? Well, that's what the management controller process will do. The controller process will get the identities from the Azure cloud using Azure APIs. Then the controller on the management station will feed this information to the firewall using Identity Awareness APIs. So next, I'm going to show you how to configure the controller to communicate to the Azure cloud and get the cloud identities using cloud APIs. We need to create a new object, a very special object. Select New, More, select Server, select Data Center. The Data Center object is a very special object that we use with CloudGuard. You can see all the different cloud versions that we support, both for the public and private clouds. In this case, let's select the Microsoft Azure Data Center object. When we click on it, we get the new Microsoft Azure object. We need to fill in the details. Let's name this object the Azure-DC. Now, there are two ways to authenticate this controller object to the Azure cloud, using either the Service Principal Authentication or using the Azure Active Directory User Authentication. You can use the Service Principal if you have the information from your cloud provider. But for me, I'm going to use the username and password. Let's fill in all the details. Once all the correct details are completed, select Test Connection, and it works perfectly. We have a solid communication connection from the controller running on a management station to the Azure cloud. Let's publish this change. This will save it in the database. Changes are being saved. Okay, now let's verify if we can now see the Azure Cloud objects in the rule base. Go to the Security and Policy tab. We're going to test this using a rule. Let's add a rule. Select Add Rule above icon. Let's call this rule Web Outbound. Select Source. Select Import. Select Data Centers. Select the Azure-DC, which is the Azure Data Center object that we just created and we just authenticated. Perfect. We can now see the cloud resource objects. Look, here is the backend subnet object that we created in the Azure Cloud in Exercise 1. And here is the front-end subnet object that we also created in Exercise 1. Here is the CloudGuard Management Station object, CPMNG. Also, we see the CGI Gateway object, which is the CloudGuard Gateway. You can search all the cloud resources in a few ways. You can search by network subscriptions, in case you have other Azure accounts or subscriptions. You can search the cloud resources by network security groups. Look, here you can even search by tags. Remember I said when we created the cloud resources that we could add tags if we wanted to. Well, if you had added tags, you can search the tag name here. Let's go to the virtual machines. Here is the web virtual machine that we created in Exercise 4. Let's select it. Let's change now the action to accept and the tracking to log. Also, I want to enable outbound NAT. So let's select the gateway object, the CGI GW. Let's go to the NAT tab and we select hide internal networks behind the gateway's external IP address. This NATs all internal IP addresses. It's a very handy and a simple way to do NATing. Select OK. Yes, again, to confirm the warning. Let's push this policy. Publish and install. Every time you make a change, you have to publish before you can install. Now, let's complete the install. View the details. The details view gives you a good view of status and any errors, if any. Good. Policy is installed. Close this dialog box. Now, I want to test this rule that we just created. Let's go back to the Azure Cloud. I want to select the web virtual machine. Let's open a serial console on the web virtual machine. It takes a few seconds to get console access. Let's log in with our username and password. Now let's ping Google. Ping 8.8.8.8. We can get ICMP echo replies. Great, we're able to ping Google from the web server. This means that both our firewall rules and NAT rules and also our routing tables are working as expected. Now let's exit this. Let's go back to the logs. let's look for ICMP packets to Google. Let's use a filter. The source will be the web server 10.0.2.4. There is a lot of traffic. I'm searching for the destination of Google and service of ICMP. Here is one. Let's click on it. Notice the source is MyWeb 10.0.2.4 and the destination is 8.8.8.8. That's Google's IP. On the NAT side, XLATE is the CGI GW external IP of 10.0.0.5. That's the gateway external IP on the front end subnet. Now let's close this log. And now that brings us to the end of this exercise. Before exiting, let's recap once again what we did in this lab. In this lab, we configured the controller. We first enabled Identity Awareness, Blade, on the gateway. We used the Identity Awareness Web API identity method. We created a CloudGuard data center object. We authenticated the data center object to the Azure cloud. Then we verified that the connection was successful. We created a rule in order to test the Azure CloudGuard data center connector object. In the source of the rule, we were able to retrieve the Azure cloud resources. We added the web virtual machine as a source and to go to any destination over any service. We pushed a policy, then we tested by pinging Google from the web server. That brings us to the completion of exercise 5. This not only ends this exercise, but also ends this lab. I sincerely hope that you found this information useful in understanding the CloudGuard network security and threat prevention product. I hope to see you again in future Checkpoint Jumpstart training videos. Until then, bye for now.